big eyebrow. Alright. Cody, okay, so we're going to talk about logarithms. Okay, logarithmic functions. So log is just another way to work with exponents.
Did I think those fourth grade letters that you hear this morning, did you notice? Maybe somebody else wants them. Okay.
Alright, so logarithms is another way to work with exponents. Okay, so last chapter, remember we were talking about inverses. How do we remember the inverse? What do we do? You put it and put it. Okay, so no, you put it later. Yes, the x and the y. Switch the x and the y. Alright? So when we switch the inverse here, we're going to get x is equal to 2 to the y. Okay, x is equal to 2 to the y power. So in general, we usually write it where b is our base. Okay, so we can say y is equal to b to the x, inverse of the x is equal to b to the y. Okay, so in the x is b to the y power, the variable y is called the logarithm.
So that's an x. Oh, isn't there a log calculator?
Yes, but we're not going to use it today. Sorry, Lindsay, what was your question?
That x equals to the y or x equals to the y?
Actually, x is equal to 2 to the y. Oh, cursor's right in front there.
What's
It's
that
that
log?
logarithm.
You either
It's logarithm like that. Don't ask me to spell that. Okay, the logarithm of x. Okay, so usually we write it like this. When we write y equals, and then we write the word log. Okay, and then we make a little subscript b, and then we put the x. And x is the same height as log. Log and x are like the same.
How do you do subscript?
On your calculator? You can't.
Well, what do you do?
Today you can't use the log button on your calculator.
Oh.
Okay. That only works when we have a base of 10. And today, but we'll get there in like the next session. Okay. Alright, so logarithms is another way to write an exponent. Logarithms are always equal to the exponent. Okay, notice here our base is b, that's our little subscript. Okay, our exponent is y, that is what the log is equal to. The log is always equal to the exponent. And then we have x here would be our
X.
the x. It's not the base, it's what it's equal to if you do the exponent, or here to be the exponent. Okay, so we're going to rewrite this one. Since the log is always equal to the exponent, my exponent is y, what's our base? What's the base? 3. 3 is our base because that's the subscript, so we're going to write it as 3 to the exponent of y, because the log is always equal to the exponent, equals 27. So in this case, we can solve it this way. 3 to the what power gives us 27? To the third. So y is going to be 3. This is basically what we're doing today. It's just rewriting so we can solve it. Okay? Yeah, but we can all be solved. Okay, this one. First example just asks us to write an exponential form. So I would look first and say, okay, remember, our logarithm is always equal to the exponent, so 3 is our exponent. What is our base? 2. So we'd say 2 to the third power equals 8, which is true because we know 2 to the third power gives us 8, so that makes sense. So we know we put it in the right order. Okay, follow with me what we're doing? Okay, on B, what's our base? 4. What's our exponent? Exponent is -4, and we say that's equal to 1 over 256. Which is true because 4 to the positive 4 is 256, negative means we put it in the bottom. Okay, do you want to do C and D, or you guys understand what we're doing? Got it? Chandler? You okay? No? Okay, where did we live to? Let's beginning.
Yeah.
Okay, so remember I said logarithms is just another way to write exponents, right?
Yes.
Okay, so if I'm looking at this, logarithm always equals the exponent. So So in this case, what is our exponent? 2, because that's what it's equal to. Our base is 4. The base is 4. This tells me 4 to the 2 gives us 16. Which is true because 4 squared is 16, right?
What do we need to do that? It's understood that that's that.
It's understood that that's that.
Yeah.
This logarithms are a way for us to figure out what an exponent is without, like, remember way back here when we were doing this, and we had to make the bases be the same before we can solve it? Okay, this is another way where we don't have to make the bases the same in order to solve it. Okay, that's what eventually we're going to
Would
use.
you say another way? So there's an easier way to this?
Easier with it. I think it's easier with this with logarithms than what we did last section. Okay, that's what we're leading on. We're going to get there eventually. I think it's the easiest thing.
Yeah, I know.
Because it wouldn't be easy if I gave it to you first.
But we'll just understand that.
Alright, let's say. So now we're writing it in logarithm form. Okay, so we're going to have to put the log. So I'm going to think, okay, we're always going to equal the exponent, so I like to bring up the exponent first. So the exponent is 3. Okay, so then I'm going to say log, and what's our base? 15, so that's what we're taking to an exponent. So my log 15, put it as a subscript, and we just move this guy over here. Okay, let's look at B. So again, I always like to say, well, it's equal to the exponent. So where is it? This is equal to half. So log base, what's our base? 4. So it's a log of base 4 of 2 is half. And actually, that's
Graph.
okay. So,
Here.
okay. All right, C. We're going to set this equal to what? Nope. 3. Exponent 3. Log, what's our subscript? 4 of 64 gives us 3. Okay, you guys get it? Okay, let's do example 3. We're at that level. So, what we're going to do is we're figuring out what this is. Okay, so I'm going to say this equals x because we don't know what it is. But a logarithm is always equal to the exponent. I said that like 10 times today. Okay, so logarithm is equal to the exponent. Okay, in this case, we're looking for the exponent. We don't know what it is. We're going to call it x. So I'm going to rewrite this so we have an exponential form. So our base is 16. Our exponent is x. We don't know what it is, but it's equal to 4. So it's a what?
It's a half.
It's a half. Because again, if we did it like we did yesterday, where we did it where the bases had to be the same, you have 2x equals 1. So like that's x is a half. So I know it's, this is a different way of doing it. Eventually we're going to do it so we don't have to mess with the bases so much. But today it's
How'd you get half?
how to get half. Wait, remember like we did earlier this week and we said, well, 16 and 4 have to be the same. Oh, I get it. So we said, well, 4 squared is 16. So now even wasn't it? Okay, so then we have 2 times x, 2x. So in this case, Alexa, we're trying to get so that the bases are the same. So 4, 16, I know 4 squared is 16. Okay, so then we have 4 and 4, that's good. So then we say, okay, well, power to a power means that we just multiply. So I have 4 to the 2 times x equals 4 to the 1. Base is the same, so that means that my exponents have to be the same. So I can just go ahead and say 2x has to equal 1, and then x is 10. Okay? Alright, let's look at B. On B, if I was going to rewrite it, how would I rewrite it so it's an exponential form?
3 to the x equals 81.
Good. 3 to the x equals 81, because we don't know what the exponent is. Logarithm is always equal to the exponent. And I need to get the basis to be the same.
So 3 to the 4 and 3.
And so x is 4. out of the plain.
But who would print paper that has Rainbow McCoy's in it?
I think it comes from probably Toshiba or some other printing company where they test their copy machines to see how many copies it can go on a single drum of ink. That's what.
So then we buy the
And then we buy the recycled paper to be used because it's
Free.
or maybe it is free. I'm not sure. I'm sure it's either really, really cheap or free. I don't know. But then if we don't have to buy more paper, then it, they don't have to then it's totally wasted. It's fine.
Words. I'm sorry for saying.
Okay, logarithmic functions. Several logarithmic functions are just exponential functions written in a different way. So they're still going to have that same curve like we were graphing before. Okay, same exact thing. We're just writing it in a different way, but they're going to have that same shape. Okay, these are pretty easy. Notice when I have a parent function, we just have f of x equals log base b of x. If b is greater than 1, meaning it's a positive number, then I know my curve is going to look like this. It's going to curve up and over. If b is between 0 and 1, meaning it is a fraction, where it's a fraction, that means it's going to curve down this way. Okay? We can graph things really easily because we can just use this information right here. Okay? So if I'm looking at this one, my base 5, is that going to make it curve up or is it going to curve down? Okay. 5 is my b, it's my base. Over here we said b is greater than 1 or b is between 0 and 1. If it's greater than 1, it curves up. If it's not fraction, it's going to curve up. So it's going to curve up. So we can just graph this. Okay? So we know, since we're not adding or subtracting anything, that it's going to hit at 1, 0. So here's 1, 0. And we can graph our point at B1. So 5, 1. 1, 2, 3, 4, 5, 1. And we can graph that 1 over B negative 1. So 1/5 negative 1. Wait, is the first point always 1, 0? In this case, if b is greater than 1, if it's a fraction, oh wait.
That doesn't.
Yeah, if it's a, nope, they're both 1. One's a fraction. Your base, but you're right, they're both going to go through 1, 0, no matter what, as long as we're not adding or subtracting anything. Yep. And we can just draw a curve.
What happens when we add and subtract?
In this section, they're not going to be fixed, but
C and D, you add and subtract. C and D, you add and subtract.
okay, well then it's just going to shift it either up, down, left, right. That's what it places. All right, with this one, since b is a fraction, which way is it going to curve up? Or down? It's going to curve down. Okay, I know it's going to go through b1. So we have 1/3, 1. I know it's going to go through 1, 0. And 1 over b, what's 1 over 1/3? 1 over 1/3 is
3.
well, times by 3, but we can just think this is the reciprocal, right? Well, so what's 1 times 3?
Wait, how did you 1/5?
How did I get 1/5 where? Over here?
How do you graph
This one. 1/5 is not 1, but close to 0. So 1/5 would be like right here. Negative 1 is not.
Wait, it
Oh,
goes
okay.
down?
Well, here, because 1/5 is close to 0. Negative 1 goes down.
Are you going to get really loopy at the end of the day?
All right, so we're looking at this one. So if I graph 1/3, 1, that makes a little over from 0, go up 1. Then we've got 1, 0, and 1, 2, 3, negative 1. So our graph looks something like that. Okay, if we wanted to, if we didn't remember these nice little kind of cheat sheet ways, we could write this guy so that it is in exponential form. How could I
Okay, 1, 0 is always.
What if it's below 0?
If it's below 0.
Like maybe in
In this case, we won't work with those.
Okay.
Okay, let's go back to this.
Y
What's going to write
equals
it?
1/3 x.
Y equals 1/3 to the x. Is this right? Because the logarithm is always equal to the exponent. What's our exponent?
Y.
Y. Exponent is y. Because it's not equal to the x. It's not true. Okay, so if we didn't remember this nice little cheaty way to figure out the points to make sure we know where it goes, we can write an exponential form and then we can just make a quick table of values and use our calculator to figure out some numbers. Well, yeah, I know. I'm just saying, if you don't remember how to do this, you can also go back to what we did before.
How do I say that?
How do you want this?
No.
This.
A little bit up. There you go.
Okay, I just looked at the table. Okay,
So we just copy underneath.
basically, this tells me that my base is 1/3, so it's actually between 0 and 1. So I just said, okay, it's going to go b plus, it's going to go through 1/3 1. It's going to go through 1 0 and then it's going to go through 1 over b negative. So 1 over 1/3 is 3. Does that make sense?
Ew.
That's makes sense. Just go to tables. All right, want to do one more? Or do you guys got it?
Wait, no. How do you do the one with like the x plus 1 and that?
Okay, with this one, remember if I'm adding or subtracting something on the end, that means it's going to go, yes, it's going to go up by 1. So I'm just shifting everything up 1.
0, 2. No, 1.
It would be 1.
No, 2. 1.
It's going to go up by 1. Up by 1. So it'd be at 1, 1. This 3 in front of it is going to stretch it. So this is one where our little cheaty ways not going to help us too much. I would write it as exponential and then just fill in the values.
Okay. Oh, wait, what's that? How would you write that? How would you write 3
Start with 3.
Okay, so remember it's always equal to our exponent, right? Okay, so our base is 10. Our exponent is y, right? Okay, so this, actually we should probably go over to 1. And so divided by 3 first. So we have minus 1 divided by 3 equals log 10x. Okay, so I just shifted everything to the log by itself, right? Okay, so this is all of our exponent here. So we have a base of 10. This whole thing is our exponent. And it's equal to x. So this is definitely one where I would use table of values.
It's easier.
That makes
Your table of values?
Wait, you can plug this into your graphic.
I'm sure there is, but I want to see what should be
So you set an x value and then just what's a y.
Yeah, 1 plus 1 something. See, and I didn't mind that.
Oh,
Now,
no.
when we start adding graphs.
Oh,
How do you graph that?
you couldn't. You put it in the table of values.
Start with 4 or 4.
I would, instead of looking at stuff for x, I would plug in stuff for y. Like, yeah, like 10 to 4 would be a good choice. Because what's 4 minus 1?
3.
3 divided by 3 is 1. Yeah, and what's 10 to the 1 is just 10, right? What's another good one we can throw in there?
How did you get that?
Yeah, that's it.
Formula.
You plug in 4 for y.
Right.
Yes, we plug
So
4.
4 minus 1
It's 3.
is
3 divided by 3
I don't
is
know.
1.
The X. Don't.
This one is off the graph. Okay, well instead of going up, let's go down. How can I make it so it's 0 exponent?
-2.
Negative 2. Negative 2 minus 1 is not 1. 1 minus 0 over 3. 0 with anything to the 0 power? 1. Yes. So we're going to go through 1, 1. Okay. power. If I want a negative 1 power, what's y?
You put negative 1 for x.
0.
0. If I put in 0, 0 minus 1 is negative 1
Why
third.
would you want that?
I want to say 1 minus 2. Minus 2 minus 1, okay, is negative 3. Negative 3 over 3 is negative 1. What's 10 to the negative 1? What would you do that in your head? 1 over 10 over 1 over 1. Yep.
I'm lazy.
Duh.
Okay, so then we would graph 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 4, somewhere way over there. 1, and then negative 2. Just gonna left something.
Told you to do that.
Like that.
Why is it 1 choose and 1 1? Negative 2.
Oh, so you're gonna put it right.
What's going on here?
Alright. It's really different when you're right here in front of the. Okay, so you want to go back to this, to how I got that. Is that what's confusing to people?
What letters in that? That? Who got that? No. That's not what I'm asking. What number is in X?
What number is in X?
For negative 2y.
Oh, 1, 1. Or 1 over 2.
Okay.
Okay, so here, remember I can say this f of x and y, right? If I treat log base 3 of x as one thing, if I was going to get it by itself, solve for it, that means I want to subtract 1 and then divide by 3. Okay, so it's like I'm saying, let me get an a. If I had this, if I want to get a by itself, what would you do?
Okay, now that what says, we should ignore the log, really.
So we say that equals a, but a was equal to the log, so that is equal to log of 3.
Okay, so basically, put a log change just 1x.
Yeah, this one.
Okay, now it makes sense.
Because then it's equal to the x.
Thinking
Our base is 3. X is y the x. Why isn't y the x one? Because the log is not by itself. When the log is by itself, it's equal to the x. Gotta get it by itself.
No, that's why I didn't x in the first place, so.
Because the log is not by itself.
Well, it's an inverse function, so it's supposed to y next to those places. That's why there's a difference.
If we were going to
In simple terms, the log, the function you're switching x and y, so here it is just the one that's y is this one.
kind of, yes.
Because that's what she asked me why it's in the first place.
All right, any other questions? You want to go through this last one?
No.
You sure? You understand what we're doing?
But it's not going to skip the next one.